Drive axle brake chambers on the Transtar 4300 model are a good example of how some simple added details can make the stock kit parts more realistic. Per the instructions, the brake chambers were assembled for the forward drive axle. These represent brake chambers with both service and parking brake functions, and although the basic shape is fairly good, there are some detail inaccuracies, in particular the long pin molded into the end of the brake chamber. For comparison, here's a real brake chamber, and although it isn't on a Transtar 4300, it is on an International with Hendrickson suspension. The overall shape and size is quite good, but the slack adjuster detail isn't represented, and instead of a long pin sticking out of the end of the brake chamber, there's a rubber plug. This image, although not of the highest resolution, does illustrate how a similar brake chamber is constructed, with the service brake portion on the left, closest to the slack adjuster, and the parking brake section behind it. Parking brakes on air brake equipped trucks are often referred to as spring brakes because they're applied with a large powerful spring and released by admitting air into the brake chamber to compress the spring. Parking brakes can be released manually using what's called a caging bolt, and this illustration does show a caging bolt in place holding the spring brake compressed. Here's a similar brand new brake chamber as supplied by the manufacturer, with the black end being where the service brake portion is located, and the gold anodized portion being the spring brake section. Two orange plugs are visible in the cast aluminum center section of the brake chamber, and these are plugging the fittings where the air brake hoses will be connected when the chamber is installed on the truck. A hole is provided in the end of the spring brake chamber to install the caging bolt if the spring brakes have to be released manually. This is covered by a rubber plug to keep dirt, water, and other contaminants out of the brake chamber during normal use. With the rubber plug removed, you can see the access hole for the caging bolt, which has a pair of lugs on the end, which, when the caging bolt is inserted and turned 90 degrees, will lock into the spring. When installed, the caging bolt projects beyond the end of the brake chamber, and this may be what Ertl was trying to replicate when they molded those pins on the end of the kit brake chambers. Back to the kit parts, which again are fairly good overall, but have some inaccuracies which can benefit from attention. One of these is this tapered pin, which although it does represent a part found on the real truck, is not an accurate shape, so it'll be removed and replaced with styrene tube. The areas highlighted in red will be removed and reshaped. Unmodified kit brake chamber on the left, along with the assortment of parts used to create the completed version shown on the right. These consist of 1/16 aluminum tube and an assortment of styrene strip, rod, discs, and O-scale turnbuckles, which are used to represent pushrod clevises. All pins and projections are removed, parting lines and seams are cleaned up, and the curved end of the mounting bracket and the right side of the image here is sanded straight, and a piece of 60 thou by 60 thou styrene strip is glued into place. This styrene strip and mounting bracket is filed and sanded to shape to provide a gluing surface to attach the brake chamber assembly to the axle. On real trucks, the brake chamber mounting bracket is an L shape, and this is represented in model form by gluing a piece of 30 thou by 60 thou styrene strip against the end of the round portion of the brake chamber. Holes will be drilled at the locations marked in red for 30 thou styrene rod, which will represent the two attaching bolts, and the brake chamber pushrod. Slack adjusters are made from styrene strip, with 40 thou by 100 thou, cut 156 thou long forming the main body of the slack adjuster, and the bottom piece is a piece of 30 thou square strip, cut 70 thou long. Glue these together on a flat surface so that one side is flush and the other has a 10,000ths of an inch step. And finish the slack adjuster with a 10 thou styrene disc approximately 80 thousandths of an inch in diameter. Clevises for the push rods can be made using O-scale model railroad turnbuckles, and this is a great example of where train-size parts in 1/48 scale become ideal truck-size parts in 1/25. One turnbuckle cut in half produces two clevises, and these are glued to short pieces of 30 thou styrene rod. Glue the push rod and clevis to the slack adjuster as shown here. I find it easier to create this subassembly on the bench rather than trying to assemble it on board the brake chamber. Next, insert the push rod into the drilled hole in the brake chamber and glue the slack adjuster and push rod assembly in place. In this picture you can also see the two pieces of 30 thou styrene rod used to represent bolts holding the brake chamber to the mounting bracket. A styrene disc approximately 1/16 inch diameter is glued to the end of the brake chamber to represent the rubber plug that covers the caging bolt hole. And the last detail item to add is a pair of 1/16 aluminum tubes, which are the fittings that the air hoses will thread into. 1/16 tube is slightly oversized for this part, but it's a convenient size to work with, and the extra size won't be noticeable once the brake chamber is painted. The kit's axle is molded with a pair of recessed circles, highlighted in red here, that the brake chambers are supposed to mount to. Comparing that to an axle on the real truck, you can see that this isn't very accurate because there's no molded recesses provided on the real axle, and this would also mount the brake chamber too far inboard. Pins were removed from the brake chamber mounting brackets when those parts were reworked earlier, and a modified number 17 chisel blade makes an excellent tool for shaving off the molded-in recesses on the axles. The brake chamber bracket will be glued to the axle in the area highlighted in red on the right-hand side of the image. Here is the brake chamber glued in place, and now there's only one more detail to be added to complete the installation, and that is a piece of 332 styrene tube cut to fit and glued in place between the brake backing plate and the brake chamber mounting bracket. This represents the torque tube through which a shaft runs, transferring motion from the push rod and slack adjuster to the brake shoes. Brake chambers provided in the kit for the rear drive axle are a style I haven't seen before in my own experience, and these look like a much smaller version of an S-cam brake without parking brake chambers fitted. I decided to model this truck with parking brakes on both drive axles, similar to a lot of trucks I've driven. I did this using identical brake chambers from the parts box, which came from another Ertl kit, and S2500, which I'd converted to single drive. And this is when I realized that all of the brake chambers in the Ertl kits are molded identical, rather than being molded as the left and the right hand, the way real brake chambers are. You can see that both of the black plastic brake chambers have the mounting bracket molded on the left side, and these in turn are identical to the white one, which is also offset to the left side. This was easy enough to correct. I simply cut off the mounting bracket, moved it over the appropriate amount to the right, and reattached. The reason for left-hand orientation on the brake chamber mounting brackets is to locate the slack adjusters so they're accessible from underneath the truck. Here the Transtar 4300 kit parts, which are molded in white, were used on opposite corners, and the corresponding black plastic pieces from the parts box, which are modified to be the opposite hand, were used on the opposing corners. What started out as a simple detail project turned into a small model in its own right, and was a lot of fun along the way. Thanks for watching this look at installing drive axle brake chambers on this model. We'll follow up with a separate installment for the steer axle brake chambers, and then cover the air brake valves and the lines at a later date.